see. Okay. So that is it right there. Okay, I'm gonna put this YouTube. Excuse me. I think you guys might have seen this before, actually. Uh, we can make reference to it later, but I'm gonna put it in the chat. Yeah, I'm gonna put in the chat. Okay. All right. So chapter 6 is a lot about IP addresses, which we've talked about quite a bit. But now let's go into maybe a little bit more specific detail here, right? So let me see how much you guys remember from the previous chapter. When we talk about IP addresses, Jojo, let me go back to you. What layer of your TCP or OSI model are you going to find stuff about IP addresses?
Would it be the network layer or internet layer?
Yeah, so network layer on the OSI model and the internetwork layer on the TCP, you're right, that's it. Okay, so that's where that is. So all devices, right, every device, computer, laptop, IoT devices, you guys might have heard of IoT. IoT. Anybody heard of IoT? Amy?
I think it's Internet of
What
Things.
IoT? Yep, Internet of Things. So what kind of what kind of things are Internet of Things?
Alexa.
Oh yeah, Alexa. There you go. Baby monitors. What? Baby monitors. Refrigerators. I hear refrigerators, right? Did I spell that right? Refrigerators?
Yeah.
Looks right.
That's fine.
So yeah, all these things now have, they can go online, get you the weather, your Fitbits. Your Fitbits can, monitor some of your medical, I guess a little bit of medical conditions here and, send stuff to your doctor. All these devices that somehow need to be on the internet to get some data or send some data, right? They all require IP addresses. They all require MAC addresses, right? For any two computers. Now, when we say computers, your mind is going to think of a physical computer on your desktop or your laptop. A computer device is literally any of these items that can go online, can exchange messages, right? Can exchange communication. And so any of those devices needs to have an IP address and stuff like that. All right. So that happens right there. When we say layer 3, that's what we just heard. I think Jojo just told us that layer 3 address, that's your internet or internetwork, right? Internetwork layer, or the network layer on the OSI model. So your IP address is typically 121, for example, .545.23.22, something like that. And we've explained, you guys did it in your assignment and your midterm about how the first two parts are generally related to your network, right? Your network. And this third octet, like we call them, the third part here is your subnet. So if you have a huge network like UMass Boston or a lot of companies, you might need to break your huge network into, little bits, so to speak, manageable sizes. And each of those sizes, or each of those chunks, so to speak, or those pieces of your network are called subnets. So you break the whole thing down. The HR is over there, the administration is over there, maybe the student services, on a set of computers, just to make it easier to manage. So this third part here is going to tell you if you have, just by looking at the IP address. So if this is 24, if this is 25, right? All these guys are on the same network because you can see the 121.45, 121.45, 121.45, same network. But you can see that the third part here is different. So it tells you that these are 3 different subnets. Now the hosts are the same, but technically these 3 guys are on 3 totally different networks. So there is no conflict, right? No 2 computers, no 2 devices can share the same IP address. There's going to be a conflict. It wouldn't work, right? It wouldn't work. So you got to have unique IP addresses for every device. All right. So like I said, we call each of this, groups of numbers separated by periods. We call them octets. You can see right here. Octets. All right. Now, this is also important information to know. We're not going to go into too much detail, but each of these octets can only be from 0 to 255. Right? It's just the way IP addresses are designed to function. Right? It can, in fact, it's not even going to get to 255. The first few numbers, maybe like the first 10, I think the first 1 to 10, and the last maybe 245 to 255 are generally reserved for like administrative purposes, right? So each of this octets here is most probably going to be between 10 and 244, 245. Each of this, they will never, right? Just because of the way the IP blocks, right? Like a block of IP addresses. The way the IP blocks are assigned, it can only be between, like from 0 to 255, but the first few and the last few are basically reserved for administrative purposes. So if you saw an IP address and you had a question, you saw this IP address, 267, not 267, yeah, 267, or, or an IP address that, says something like, 321. And you ask, is this IP address valid? It is totally invalid. None of these numbers should ever exceed 255. Never. It just doesn't work. Right? So that's like a set rule. IP addresses go from 0 to 255 because of the way the IP blocks are distributed. All right? And we also said that each host ID, so the host ID, so let's get rid of this guy's here. The host ID is the last part here, right? When you say your host, you refer to the computer you're on, that device, right? That's your ID. This tells us that this person, 22, of course you have 22, 23, 24, and all that stuff. So every host, every computer has a unique IP address in that network. It helps us to know what computer is sending what message. There's no conflict. It's a very unique kind of ID. All right. So here is another issue here, or here is something else we should talk about. So it says due to the popularity of TCP on the internet, we're running out of IP addresses. In fact, some people believe that we've actually run out of IP addresses. Now with IPv4, and this information is in your book, we're going to go all the way to chapter 6, but we're going to page 294 is where we're starting from. Page 294. So, or maybe I'll just say 292, right? Just some background information in 292. Okay.
Quick question. So what do you mean, like, we've run out of IP addresses? Like,
I'm going to give you that in a second.
oh, okay.
That's a good question. So some of this background information is on page 292, and we're going to get into it in a second. All right. So why are we running out of IP? What does that mean? Let's go here, and let's say number of IPv4 addresses. All right. So look at this here, this information. Now, this information here, it tells you how many IP addresses actually exist. And what's this number here? This is like 4 billion? Am I right? Hello, anybody here? Can you give me some feedback?
Yeah, that's
It's
right.
about 4 billion, right?
4.3 almost.
Okay, so here's the question. We have about 7 billion people, right? On the planet, so to speak, right? Plus or minus. Now, let's just say about, I don't know what a good estimate is, but let me just go with 10%, right? So let's say 10%. That might be too low, but I'm just going to go with 10%. So let's say 10% of 7 billion people, which is what? What's 10% of 7 billion? 700? What's 10%? 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So 10% is exactly what? 700 million. Okay. So if we said 700 million, so 10% of the population, right? Say that 10%, people have about 3 or 4 devices to each person, right? If we go conservatively and say, well, that 10% has at least 2 devices to each person, right? Now, 2 devices, what does that mean? It means that you've got, and it's certainly much more than 2. But if we just go with that conservatively, right, we say 700 million times my original number of 4, right? This gives us half of this number. Am I correct? About half. This is like almost 3 billion. Now we've got 4 billion here. So we know that most certainly my 10% of the population is it's grossly, very low number, because a lot of people have devices around the world. Not everybody, but a lot. So maybe not even 10. Maybe we should go to 20% or 30%, right? Have 2, 3, 4 devices each. So the point is, when the internet started, we've covered this before, right? When computers started, there was no internet. Nobody was going to any online shopping, going to Netflix. There was none of that online stuff happening. So there was no requirement for IP addresses. Now, let me tell you how crazy this sounds, right, Michael? Mm-hmm. If let's say you put on the news, right, later today, and you heard this thing about, in 5 years, every adult in the United States and around the world is going to have a plane, like a little jet, right, in your driveway in 5 years. Okay. Done deal. They're just going to say, "Oh, you guys are crazy again." Is that who said that? Is that Elon Musk? going at it again, right? It sounds impossible. Like what? In 5 years, like everyone is going to have a jet in their driveway? First of all, we need bigger driveways, right? And how are we going to coordinate all that? It sounds totally impossible. Well, 40, 50 years ago, when the idea of the internet came about and the organization that sets up the whole thing said, okay, well, we're going to put out 4 billion IP addresses. Nobody ever thought we're going to, it's never going to be maxed out. You know,
Right.
people just felt like nobody's going on the internet, so nobody's going to even need it.
We
No one is
progressively
gonna
need to
need it.
future-proof. I mean, Y2K, perfect example. We didn't know what the hell was going on.
Exactly. So I would say that in a sense, there was, I guess people underestimated the needs. And so we're getting to a point where, or we have probably gone past the point, right, where IP addresses, because of the amount of devices that are available, right, are not sufficient, are grossly insufficient for what we need them to do. IP addresses, right? So that's why we talk about IP addresses running out or have run out, because you have so many devices. All these devices need to have an IP address, and we just can't cope. It's kind of like having so many people who need to get onto a train, and we just don't have enough trains, maybe, right? Stuff like that. So that's why there's a talk about IP addresses running out. Now let's see. I mean, there's solutions in place. So let's keep going here, and then we see what kind of solutions that there are in place. All right. So now we're going to talk about what we call private IPs, public IPs, reserved IP addresses. Now, if you look at page 292/293, we see there, actually, I think it's better to go to, all right, so page 292 tells us, just like we see in the PowerPoint here, that we have a few classes of IP addresses. It's like all the IP addresses are grouped. In fact, there's a table right there on page 295, right? That kind of gives you the grouping. So you have Class A, Class B, and Class C IP addresses, right? It's very important to know why these are the way they are. So let's see what the description is about these different classes. You know, what does this mean? So on page 292, we can see there that IP addresses are categorized in ranges referred to as classes A, B, C, D, or E, but the most common are A, B, and C. Now it says here, only IP addresses in the A, B, and C classes can be assigned to a network device, right? So you're going to see questions about this. You also want to be knowledgeable about this. I mean, as an IT student, if there is anything at all you should be familiar with, is the idea of IP addresses, because it's such a common thing, you know, that you got to know about it. So only ABC classes can be assigned to a network device. So basically, D and E, we don't use those. All right, now let's go down that same page 292. Now let's look at Class A. What's the issue with Class A? The value of the first octets. So when we say octets, right? So here's what we mean by octets. Octet is this first number here. It's between 0 and 127. Okay. Now remember that it goes all the way from 0 to 255, right? That's where it ends. But for Class A goes from 0 to 127. Now, Class A addresses were intended for use by large corporations and governments, right? So generally, if you see an IP address, right, with the first octet ranging from 0 to 127, then you probably have an idea that it's what kind of a organization it is. So all IP addresses are assigned by registries, right? Maybe like web hosting companies and things like that. Now it says that the last 3 octets are left up to the network administrator. So the first octet is assigned by a registry, like an organization that does that kind of job. So in a Class A IP address, such as 10.159.44.201, the network address, it tells us that the 10, just like I said, right? The first octet always tells you the network itself. So that's the unique thing. Now let's see this. Part of Class A, it says that Class A has about 16 million, right? 16 million plus hosts per network address. So basically, a company or an organization that has a Class A IP can have as many as 16 million computers or devices in its network. 16 million. If you have a Class A IP, you can have as many as 16 million plus, almost 17 million here, devices in your network. So you can imagine what kind of company is going to have 16 million employees, right? So you got to be a very large corporation or government, or some kind of a serious international company to have a Class A IP address. All right. So let's go to Class B. So Class A goes from 0 to 127. Class B goes from 128 to, remember we're talking about the first octet here, right? The first part, this first part. Class B addresses go from 128 to 191 and were intended for use in medium to large networks. Now those guys can have about 65,000 hosts in their network. All right? About 65,000. So a Class A is for, it's like a government company or a large corporation. A Class B is for medium, 65,000. Right? And the first octet there goes from 128 to 191. So just by looking at an IP address, you can safely guess the size of the company. Let's go to Class C. Class C addresses on page 294. Class C addresses were intended for small networks. And these guys have about 254 hosts per network for small networks. So I guess this would be for most networks, right? I mean, things like at home, in a small company, probably in a lot of, medium, small size companies will have Class C addresses. So Class C addresses, the first octet goes from 192 to 223, the very first octet. So if you see an IP address with, like it says in that example, 203, it gives you an idea that it's a Class C address. Class D and E don't really concern us, so we're not going to go there too much. So look at that table, table 6.4 on page 295. You can see there that the class is listed, Class A, B, and C, and it gives you like a breakdown. So the value of the first octet in Class A is 0 to 127, Class B is 128 to 191, Class C is 192 to 223. Okay? The maximum number of hosts per network, Class A is 16 million plus, Class B is 65,000 plus, and Class C is 254. All right? Gives you an idea of the size of the network and what class, if it's a Class A, a Class B, or a Class C network. All right, so now let's look at this here. So I'm going to pull up my IP address. I know what my IP address is, but let's look at it. IP config. And let me look for my Ethernet adapter here. Okay, let me do this. Okay, where is it? Okay, so right here, where am I seeing here? Ethernet adapter 4, Ethernet adapter, Ethernet. Okay, so actually, let's do this. Let's say what's my IP. Let's do this. All right. So right here. So Jared, tell me what class of IP does this IP address, this public IP I'm talking about, what is it? What class does it fall in?
That's
Based on what we
class,
just looked at now.
that's class A, right?
You tell me.
I'm pretty sure that's class A.
Why?
It falls in between 0 through 127.
So why will it be class A? I mean, I'm right here in my house, right? I mean, obviously, I'm not a large, corporation or company. So why will I have, a class A IP address?
How do I explain this?
Try in English. Try in English.
So like you're on the internet, right? That's like the IP address that like communicates. So like you're in the internet, like you're talking through everything. So you want to have like a value probably between that 0 through 127.
Well, good attempt, Jared. I'm scratching my head now, Jared, saying, what did Jared just say? But I think you have the idea. Let me go to Brooke. Brooke, what do you think? Why do I have a Class A IP address?
Maybe because your ISP is a large provider, so they're the ones who has the Class A IP, and then that's just given to you.
Dennis, do you agree with that? That is from my ISP?
Yes.
I think so, Jared. I think so. I think so because, we don't control, our own networks, right? You're going through Verizon or you're going through Comcast or RCN or AT&T, any of these guys, right? And so you're part of their network. And obviously, Comcast and Verizon are like global, multi-user companies. So obviously, those guys, you're part of their network, and they are Class A providers. So that's how you get that kind of a Class A IP, because you're part of a very, very, very large organization, right? So that's a good one right there. Okay, well, let's move on here a little bit. Let's see what else we got. So it's important for you to understand that background, all right? The background of, the classes of IP addresses. Okay. Now, let's also talk about something here besides the categorization here. We also have to talk about the private IPs, right? When we say private IPs, so right here on page 295, we'll just look first of all at the classes of IPs, right? The different classes, class A, B, C, and D, and E. But now let's look at the private nature of the IP. So 295 says each device that accesses the internet must do so using a public IP address. So back to you, Brooke. If you look at my IP here, right? The IP I have on my screen, this IP we just talked about, and this IP that I have for my computer, you see there's a difference?
Yeah.
There's a difference, right?
Mm-hmm.
And you might think, okay, what is going on here? Why do we have a difference? So here's what let's talk about that. So 295 says each device that's going to access the internet must do so using a public IP address. So obviously, my accessing the internet is not based on this private IP here. It's based on this public IP. And then it says because of the of the popularity of TCP/IP, IP addresses are almost exhausted. So we talked about that. So to help solve this problem or alleviate this problem, the government body, responsible, came up with reserved addresses. Reserved addresses. All right. So reserved addresses. So in the class A group, right? In the class, so this is, don't get confused by this. We just talk about different classes of IPs, right? And how many, the range of, like the, how their first octets are assigned. Class A is 0 to 127. Class B is 128 to 191. Class C is 192 to 223. Okay, so let's go back to Class A. So in the Class A, we have reserved addresses, right? So Class A addresses beginning with 10, right? Beginning with 10 are reserved, right? In Class A, addresses beginning with 10 are all private reserved addresses. In Class B, addresses beginning with, what's to say there now? 172 to 172.16 to 172.31, right? Like 16, network addresses basically. Private IPs in the Class B range. Then in Class C, we have 256 network addresses between 192.168 to 192.168.255. Dot. I said point there, right? Dot. So those, should I say those subcategories of IP addresses, right, extracted from the big group of IP addresses are private IP addresses reserved. So if you look at my IP address here, right, I have a Class A public IP address, and I have a Class A private IP address. So in that range, in the Class A range between 0 and 127, right, if an address begins with 10, it's reserved for private use. Now, what does that mean, private use? It says right there on that page 295, the addresses in these ranges can't be routed across the internet, which is why any organization can use them to assign IP addresses. Let me talk about that a little bit so you guys get what I'm saying, what we're talking about here. So this IP address I have here, this private IP, just like you guys have on your computer, this IP address cannot function on the internet. If all I had was this IP address, I wouldn't be able to get on the internet. Absolutely not. It's not designed to go on the internet. It's designed for a private network. When I'm going to go on the internet, my router, right, has to provide a public IP address for me to get on the internet. That's why that video that I sent to you guys in the chat earlier kind of gives us some information about that. So you want to watch that video. But let's go to this explanation here. So, Brooke, I'm going to go back to you again. So let's say, for example, we have, I'm just going to guess here, 1 Main Street. Brooke, tell me, where can we find 1 Main Street?
Like on
what town? What city?
Oh, probably any city.
Exactly, right? It's like everywhere has Main Street. Okay, but how do we? So we agree that a lot of cities, or every city, right? Every town can share that address, 1 Main Street. But what makes it different? You're going to have an IP. You're going to have a zip code that is 02472, right? 02473, 473, 02474, 0202475, something like that, right? So if you send out, a package to 1 Main Street, right? Well, there's 1 Main Street in all the zip codes here. What makes it different is not the address, it's the zip code. So the address one main street, you're going to find in every zip code. Just like, so this is, so your one main street here, we can compare that to your private IP, right? Your private IP. A lot of networks, a lot of companies, a lot of homes, a lot of, offices, schools, right, share IP addresses. In fact, on your computer at home, you can probably look at your IP address, and you might actually have an IP address that is 10.0.0.112. The first time I noticed this, I was totally confused. This was like a long time ago, right? When I was like an IT rookie. I was totally confused because I went out with my boss to this other company, and I noticed that the IP addresses were very similar to what we had in our company. And I thought, this makes no sense. How are we going to have the same IPs? But later, I got more information. I realized what you see when you use your command prompt is most probably your private IP address. Because of the shortage of IP addresses, this design was put in place, right? So that in private networks at home, in your company, at your school, you can have different schools, different companies, right, can share similar IP addresses because it's in your private network. Just like you can go to different towns and you can share the same name of a street, right? Main Street, one Main Street. But every town, right, is unique in every town. You're not going to have two of these addresses in the same town. It's not going to happen, right? You can have two buildings that are one Main Street in the same town. That doesn't work. Every building, has a unique address. But in every zip code, you can have, like similarities there. So when we talk about your IP addresses, the address you see on your computer when you do your command prompt is a private IP. That IP is only for use in your private network. This was how things were designed initially, I believe, because nobody was going out to any internet. But when you do need to go on the internet, right there on page 295, that same page we're on, there's something that we call network address translation. Let me go to it here. I will get to it in a second. Right here. Network address translation. This is a very important concept in networking. It says network address translation, NAT. Right? NAT allows an organization to use private IP addresses while connected to the internet. So my private IP here, just like what you guys have, right? When I want to connect to the internet, my computer has to talk to the router and go through network address translation. What that means is the NAT process translates a workstation's private address into a valid public internet address. So many organizations can share similar IP addresses because they're private. They're within your network. But when you're going to go out there on the internet, it changes that from a private to a public that's able to function on the internet. And so you're going to find a lot of, if you live around where I live, you might have the same public IP as myself because we live in the same area. It's very possible, right? Because we're all under the same network if you live around where I live, right? But our private IPs might be the same, right? We might share, thanks to, our provider, and stuff like that. So it says here that when your packet is leaving your computer or your network, right, it's going to package, it adds your private IP to the public IP because when data returns to the workstation, the address is translated back to the original private IP address. So it's part of the data that's going out. Because when we come back to you, we have to know what computer sent this message or is going to receive this message back. So all that stuff is added to your data as it moves out. Your private IP is attached to the public IP on its way back, so we know how to get it back to you. Right? So this network address translation is usually handled by your router. Right? And just like your switch has a switching table and the router has a routing table, well, your router has a network address translation table. So it's able to keep track of this craziness of IP addresses going from public to private and back. Let me see. Harvey, does this kind of make sense to you? I just want to try to confuse you guys.
Yeah, I'm getting it.
Make some sense? Cindy,
Yeah.
does it make sense?
Yeah.
All right, so we talked about this a little bit before on that same 295, what we call APIPA, right? The APIPA addresses. Where's the APIPA? I don't think do I have it here? I don't have it here. But I have it there. It's right there on page 295. So we talked about DHCP, right? When you have a DHCP, basically when you're part of a network, just like I have DHCP enabled here. I mean, if you're on any kind of internet, you most certainly have DHCP enabled on your computer, so you can see your DHCP is enabled, which means I'm part of a larger network. Now, like we talked about a couple of, I think, classes ago, if I disconnect my computer from the internet and I grab two computers and I daisy chain those two computers, connect them directly together. No network here, just two computers talking directly to each other, right? Well, there's no IP address that's going to be available. There's no class A, class B, class C, whatever. It's not going to be available. But here's what happens. So right there on page 295, it tells us that another term, it says another type of IP address is a link local address. It's not assigned manually or through DHCP. It's assigned automatically when a computer is configured to receive an IP address through DHCP, but no DHCP service is available. Basically, you're not connected to your internet. You're not connected to your router. You're just kind of like a standalone computer. So when that happens, and you have two standalone computers that are connected together, it says another type of address called APIPA, right, is assigned to those computers so they can talk. Now, where do we get the IP addresses from for APIPA? Michael, where do we get the IP addresses from for APIPA? What do you think? What class is this selection from? Michael?
Sorry, I was muted on my mic side. Class B.
All right, how do you know it's class B?
I want to say because of the range.
The first octet, Michael, the first octet. So the range for class B is what, Michael?
The range for class, let me think. So for class A it was 0 to 127. For class B is 128 to 191. Sorry, 0 to 127 for class A. Class B is 128 to 191.
So a APIPA range is what number? The first octet?
The first octet in wait a minute. On your IP address on the screen you're sharing?
No. APIPA. What we see in the book.
Oh, okay, yeah. APIPA. See, the value of the first octet is 128 to 191. So that is going to be, I believe it's going to be the first octet, right?
Yeah. So APIPA starts for 169, right?
Yeah.
And that falls between 128 and 191, the class B.
Correct.
Make sense? Are you confused?
Oh yeah.
Makes sense, right?
No. I'm not confused. That makes perfect sense to me.
All right. So APIPA addresses, right, that are reserved for what we call standalone situations, right, are in the B range. Just a very small subset, in the B range. 169 to 169.254.1 to 169.25. So it's kind of like 253 devices. So in every network, if you have standalone devices, where you can have a bunch of computers, you can have up, over 200 computers that are standalones, and they're going to get the IPs that can talk to each other. But there's no internet for those guys. So it says that these guys can only communicate on a local area network on a LAN. There's no router. There's no router. They don't work with the router. Just work privately. So,
Okay.
So it's a private system in a private network.
Right. That seems. Well, I mean, I guess it depends on the environment you're working in, right? But it doesn't seem very ideal for most organizations. Being tied to only local.
Well, think about it this way, right? You have a large company, you have all your business, your accounting, HR, your IT, all that stuff happening.
Yeah.
Well, suppose you want to have you want to have a secure network. You don't have it, let's say accounting, for example. Let's just say accounting department, right? Mm-hmm. Every single computer in the accounting department is connected to each other, and but there's no internet connected there.
Right.
Right? If you need to go to the internet, maybe they have a reserved computer in the other room you can go to and get on the internet. Right? I think it's going to create some incredible security because you have absolutely zero interference coming from the outside.
Absolutely. So I guess the idea would be doing things that way. Then at the end of the day, when you're ready to upload things to so everyone else can see it, or they need it on a network, they can later upload it to a private drive.
Why not?
Yeah, that's
Why
great.
not? I mean, we're not saying shut down the internet. No, we're saying you don't have to be there on the internet if you're in this department, or if you're in this, in that department, or you're doing this particular job or particular work. Mm-hmm. And if you need to go to the internet, well, you can get on the internet, like you said, at the end of the day or something. It's a strategy for security. It's a strategy for security. So, why not?
Yeah.
I mean, after all, we all know how much trouble, companies, attack from, just being on the internet. In fact, somebody says that if you want to disappear, Michael, if you want to disappear, just unplug yourself from the internet. It's going to be like going out to live in the woods. Nobody can find you. You're kind of surviving on, firewood and, crickets,
It actually
Nobody
sounds
can
nice
find you.
sometimes.
Yeah. Anthony, how does that sound? I mean, do you think this can create some added security, or is it like, nah, who needs this?
Wouldn't it also depend on the size of the company? Because what if you have a department that needs to be on the internet? Or would you strictly only reserve that for, I don't want to say less important departments, but yeah, I guess departments that don't necessarily need to have internet access? Because I guess in that case, it would make more sense.
Yeah. I mean, you got to look at it on a case-by-case basis, right?
Yeah.
I mean, do you need to be on the internet 24/7? Maybe. Who knows, right?
Yeah.
Maybe, maybe not.
Yeah.
It depends on the job, exactly. It depends on the job.
Just for some real world stuff. One second, am I muted? No, I'm not. Okay. For some real world stuff, I started an IT job probably about 2 weeks ago. And one of our responsibilities is we have estimators, and we have these hard drives that have all information for these $300 million projects. And whenever an estimator wants access to that drive, they have to go through us. And depending on what folders they want to go into, we have to speak with their supervisor to make sure they're allowed to go in there. And then we go through Active Directory to do all kinds of stuff for them.
That's excellent.
So again, in that case, we do have an accounting department. They do have their hard drives, but they're allowed to do it. We have BitLockers on them and stuff like that. So I can definitely see how companies would prefer to do it that way, where everything's offline until, okay, now it's time to update the hard drive to whatever they need. But it's a redundancy thing too, because the problem with being off of of a local network is you don't have redundancy. You're not on a cloud device. Everything's not being backed up. So it's different risks for different situations.
Yeah, of course. So like we said, yeah, you gotta look at the situation. Okay, do we need this or do we not need it? Everyone makes a decision, but you know that you have the tools. You know, you have the tools. You don't have to. I mean, for example, if I disconnected from the internet, I wouldn't have to worry about antivirus. You know what I mean? I wouldn't have to worry about antivirus because there is no way I'm getting a virus except I, corrupted my computer for, through some reason. So a lot of the problems that we have, just looking at things on one side of things, on one side of the picture of the coin, is just connecting to the internet. It's like this, all this information coming through. I mean, all you need to do is run, run Wireshark on your computer and just see all the traffic that's coming through your system. All right, so a couple more things here. So we jump all the way to, let's see. We're not talking about subnetting, not subnetting at all. We're jumping all that stuff. Yeah, so the various commands that we use, you guys have done some of this in your assignments in the past. Like the route command, when you want to, you want to see the route your packets take, right? Going from point A to point B, we use the route command. And here are the other tools that are available: ipconfig, the ping, trace route, NSLOOKUP. These are things that you're going to, have tasks to do part of your assignment. They're all connected to, IP. I mean, ping is very important in an IP in a company. You want to know if the computer is active. You do your ping. We've done that a few times. If I want to ping on a umb.edu, for example, pinging allows you to know if the computer is, so to speak, if it's awake. And it also gives you an idea of the IP address. So right here, I didn't even know what the IP is. I just used the actual domain name, and it returns the IP address. It also returns things like the TTL, which is your time to live. Your time to live is like an expiry date. It's the estimated amount of time for this message to go back and forth. It says it right here. The approximate round trip time. So if you say, for example, I did this, if I did something like this, right? I mean, there's no address like that, but if I did a ping, well, it's going to tell you it doesn't exist. So it's a way for you to know if a number, or if an address exists, or if it's going to, be able to respond to you. And in a local area network, it's something that you use a lot because you're always troubleshooting computers. You want to know if these computers are awake, are active, or if there's some other thing you have to figure out with those computers. So all these tools are available to us. Now you also have this, should I say, options with ipconfig. So a couple of them we should look at here. If you want to, now sometimes you're troubleshooting computers. I mean, I've done this a lot in the past myself. Where is it? ipconfig. So you're troubleshooting computers. There's a problem with the IP address. You just can't figure out what it is. Well, here's an option you can use. You don't want to do it now. Do it when we're done with class because it's basically going to kill your internet. But when you use the option ipconfig/release, what it does is it releases your IP address. Right? Basically, it disconnects you, right? So it releases your IP address, and then when you're done with that, in a couple of moments, then you can do renew. Renew is basically give me a new IP address, right? So when you're having some kind of connection problems in your network, that's one option to use. It's the release and renew, and generally, it might actually give you the same IP, but it will probably give you a different IP because when you release the one you have for some connection problems and renew, you get a different IP. So it's one of those options that we have when we're trying to troubleshoot the computer. We just looked at the ping. It's important to see some of the info attached to the ping responses here. In the ping response, you always have 4 packets returned. When you run ping, it always just returns 4, just by default. You can see the amount of time it takes. It takes the TTL here, time to live. It gives you the amount of packets that were sent, received, no loss here, 0% loss, which is good. You always aim for 0% loss. That is, nothing was lost. There were no errors, no issues there. It gives you the approximate round trip time in milliseconds. So approximately, 43 milliseconds for the round trip time. I mean, imagine if I could go to UMass Boston and back, like for real, in 43 milliseconds. That would be totally awesome, you know. But this is all logical traveling here. So we looked at network address translation. I think we're going to find that info. All the other info, we just talked about the different commands, page 312, 313, 314. Your network address translation information is on page 317. Now let's look briefly at the last part, which is IP address, IP6. So IP6 is the new IP address, let me say, right? 40, 50 years ago was when IPv4 was developed. And not too long after, people realized, well, we're going to have problems. So now let's look at something. When we did the first search, right, we had 4 million IP addresses, 4 billion for IPv4. Okay, let's compare that with IPv6. What do we have? IPv6. Anthony, you want to help us with what this number is here? This is like how many here?
It's
well, let's just go here.
Yeah.
This is like
340 trillion IP addresses.
Now, would you say that when you compare that to 4 billion, is that like a lot?
Oh yeah, that's definitely a lot.
Yeah. So at this point, you probably feel like there's no way we're going to exhaust, 340 trillion, like never, right? But that was what happened back then when it was like 40, 50 years ago. Oh, whenever we're going to exhaust 4 billion. So, but that's the next, should I say, evolution of IP addresses, right? The next version of IP addresses is your IPv6. So IPv6 obviously have a larger, much larger, pool of numbers to pull from. So it has a larger address space. Your IPv6 address looks like this. Where is it? Looks like I think I have some of it here already. Yeah. So here's the IPv6 address. Where is it? Right here. So you can see what it looks like. It certainly looks very different from your IPv4, right? It actually looks kind of like a MAC address. So here's a MAC address here. The MAC address is kind of separated with dashes. But your IPv6 is separated with colons. Sorry. Yeah, that's a colon, right? COLON. That's a colon. And it's much longer. So IP addresses are, going to replace, at a point, they're going to replace IPv4s. And of course, if you also go into your control panel, you're going to see the IPv6. We have the IPv6 capability. If you go to the properties of your Ethernet, you're going to see down here that you have IPv4 and IPv6. IPv6 properties are slightly different from IPv4, but again, you have the options to, automatically have it configured without having to do any manual stuff there. So in terms of the characteristics, the way it looks, the way it's written out is different. It has more info. So it has more numbers available. We just looked at that 340 trillion compared to IPv4. So when IPv4 eventually runs out, then IPv6 is the replacement for IPv4. We have a few technologies that are responsible for, should I say, helping with the whole change and the whole, transition from IPv4 to IPv6. And you see some of those guys at page 329. So you have the dual IP layer architecture. You have IPv6 over IPv4 tunneling, intra-site automatic tunneling address protocol, 6 to 4. There are a few there that you might just want to take a glance at to see what they're talking about. So that's going to be the translation when eventually some people say that it's, we've run out of IP addresses completely. Some people are like, we're about to run out of IP addresses. But whatever happens, we need to have the infrastructure. Just like I said, just like the example I gave, the crazy example that in 5 years we're all going to have jets. I mean, it's like let's even forget about jets. How about electric vehicles, electric cars, right? So there needs to be, when you're going to have a major change like IPv4 to IPv6, you have to have the technology in place. And when you read those few pages, you see that the kind of technology that we have to have and how computers have to be configured and all the cabling and all the communication, equipment that we need have to be able to work with IPv6. So for any translation from, or any, should I say, upgrade in technology, you have to have, all the resources in place. If they're going to have, electric cars, then you have to have more charging stations. Maybe the price has to be cheaper, right? If you want people to afford it and be able to use it. So just like with IPv also, right? So the more we go from IPv4 to IPv6, then there's got to be a lot of work to make sure that, all the devices that we have can comfortably work with that new technology. And that's all we got for chapter 6. I told you it was a very short chapter. Some things we don't need there. And that's all we got. Let's do the attendance and then see if you guys have any questions.